Incoming EC Web Setting Tutorial. Tutorial video number 10. Grid Settings. All grid-related settings has to be done under the settings in the EC Web. When you click on the settings under the category, you will be navigated to main settings page. There you have the option to select port 2 or port 3. Modbus RTU communication for grid can be established only at port 2 connection. Therefore you should make sure the correct port 2 selection for this settings. The main setting page have variety of editing options for grid settings. Here the first editing you have to start with measurement setting for the grid. This setting refer the load readings of the site when the controller parallel with PV system. The first editing for sensing method for grid control references to the ECPV2. Sensing method setting determines what power readings to base the calculated references by ECPV2. There are 3 options available, which are 3 sensing, 3 lowest phase and sum of all phase. Sum of all phases option will be used for 0 kW export sites. When you use this setting, the controller will do the controlling function based on the total loads on all phases. The controlling will be regardless of any asymmetrical loads. The next option is 3 lower phase, which will be also used for 0 kW export sites, but the controller identify the lowest phase and multiply by 3 to get the real value of the load. However, this setting will not disregard the asymmetrical loads and will be useful for 0 export on any phases, but it may allow imports in some phases. The last option is 3 sensing, which will be used for the sites with symmetrical loads and installed with one current transformer. Here the controller will sense the one phase and assume the other phases has the same value, and the controller multiply the received phase value by 3 to get the total value of the load. The next editing option is for origin of main breaker position feedback. The main breaker feedback origin determines from which source the mains breaker position closed feedbacks arises. Here you have 5 setting options to use. The first option is fixed on. This setting will be used for self-consumption sites where no gensets connected. Here the fixed on setting refer the controller that the main breaker position is always closed. Fixed on setting will be a reference to the controller for controlling function regardless which circuit breaker is connected. Which means the controller consider the main circuit breaker is connected always. The next option is meter communication. If the site installed with power meter, then the input 1 of the power meter will be interpreted as mains breaker closed feedback. For this settings, the main circuit breaker has to be connected to the power meter. Then the controller will take the information from input 1 of power meter. EC logic is the next option. This option will be used in complicated electrical infrastructures where the utility cannot be counted from common AC busbar as the utility is not connected to the same PV busbar. In such installation, the utility condition can be customized within EC logic. The next setting option is all GB off. This setting can be applicable when the gensets are not in use or switched off scenarios. In case all GB are off and there is no genset communication alarm present, the ECPV2 will interpret as the mains breaker position is closed. This setting mostly applicable where the situation of automatic transfer switch will be either connected to genset or main grid, and not during a situation where both connection will be used at the same time for the utility. The last option is Modbus page 3. This setting will be used for situation during the ECPV2 have to use the grid power data for interpreting the breaker position, which is written from a superior controller to the ECPV2 proprietary Modbus map page. Next setting under the measurement is kW origin. Kilowatt origin determines from where to retrieve or calculating the grid power production. This setting has three options, which are Mains meter, Modbus page 03, PV communication. When you use the main power meter setting, ECPV2 will summarize all the connected power meter readings to a collective total of the connected grid power export and import measurements. Up to 16 power meters for sensing the grid production can be installed for this setting. The next setting option is Modbus page 3. This setting allows the ECPV2 to use the grid power data written from a superior controller to the ECPV2 proprietary Modbus map page 3. And the other alternative is PV communication. Here the ECPV2 will acquire the active and reactive power readings from this meter via the PV communication. This setting will be useful for some inverter managers which supporting data acquisition from a power meter installed at the grid connection. Kilowatt-hour origin determines how to calculate or retrieve the imported and exported grid energy. This energy calculation setting supported by two methods. First method is ECPV2. In this setting the ECPV2 integrates energy counters itself based on measured kW. The second method is power meters. During this setting the ECPV2 will read the total energy counter from the power meters and summarize the readings. Based on this readings the ECPV2 derive daily, monthly, and yearly energy counters. The installed power meter must provide both the total energy export counter and the total energy import counter in order to make use of this approach. In the references edits you have to edit to main active power control and its references. Main reactive power control and its references. NCOSFI reference. The main active power setting has two options. The first option is fixed PPCC, which is fixed power point of common coupling. This settings will keep the active power production fixed at the point of connection to utility. This is therefore to be the selected method for doing self-consumption zero export operation. The alternative option is fixed P. This selection will keep the production of active PV power fixed. The P reference setting value will be the reference for the main power control setting. For instance, if you use fixed power point of common coupling setting with the P reference 50 kW, then the controller will maintain the 50 kW energy flow at the main connection, which means that depends on the utility load. The PV production will be increased or reduced to maintain 50 kW energy flow at the main connection. Above mentioned all three measurement selections can be used for both fixed P and fixed PCC control methods. In scenarios sum of all phases has used for fixed PCC, and 0 kW rev, you risk export on one or two of the phases at asymmetric load. In case 3 lowest phase has used with fixed PCC, and 0 kW rev, you will get 0 kW on the least loaded phase and import on one or two of the other phases at asymmetric load. Alternatively, if you use the fixed power settings, the PV energy production will be fixed to the P reference. Here in the next main reactive power setting you will set how the reactive power will be controlled. The reactive power control will be controlled by the ECPV2 based on the Q reference you have set on the reactive power reference. Fixed Q settings means that main connection will produce fixed reactive energy you have set on the Q reference. If you choose the fixed Q point of common coupling, the controller will maintain the reference Q value at main grid connection. Even the Q consumption goes up in the utility by producing more reactive power in PV plan. The fixed COSV settings maintain the set range COSV values in the main connection regardless the fluctuation of reactive power in the utility. Fixed COSV C or fixed COSV I setting will keep the COSV of the PV plant fixed, both running capacities and inductive respectively. The next option is fixed COSV C point of common coupling or fixed COSV I point of common coupling. This setting will keep the COSV at point of connection to utility is fixed on both capacitive and inductive respectively. The next setting is main active power frequency range setting. Here you can set the preferred grid power frequency. Grid power support will not be affected within the frequency band setting. If grid power frequency goes above or below the dead band, the reference is set equal to the PV power. The reference will be altered according to the frequency and the respective slopes. Frequencies above or below cutoff thresholds do not contribute to further alteration. If this setting is not relevant, you can disable the setting. The next setting is Grid Support U, which is for the correlation between grid voltage changes and reactive power. Here you can set preferred grid voltage in order to create a condition where the reactive power do not get affect. Which means within a defined dead band the reactive power reference is unaffected by the grid support. When voltage goes above or below, at that instance the reference is set equal to the PV reactive power. Here you can set preferred grid voltage in order to create a condition where the reactive power do not get affect. Which means within a defined dead band the reactive power reference is unaffected by the grid support. When voltage goes above or below, at that instance the reference is set equal to the PV reactive power. In case if the voltage goes above or below the set band, the reference is then altered according to the voltage and the respective slopes. During this scenarios the voltages above or below the references will be cut off. Once voltage returns within the defined dead band, the references are again passed by without interference from the grid support. If you do not need this setting, keep this setting disabled. The next setting is Rated setting, which setting will use to fill out the grid connection power rates. You have to fill your grid power rating here. The ECPV2 will use the values for alarms and other correlated control function with genset and PV production. The next setting is Import and Export Revenue Value Settings. Please refer the genset setting video tutorials for this settings. Thank you for watching the video. This video presented by Nkumi. For more information please visit our website www.mcomb.com.